and the main part of collaborations workshop, and we're rounding it out with a keynote. And again, I will actually not do much of the talking again. For this one, I've engaged James to chair the session, and he'll introduce the speaker for the session. And I'll just point you to Slido again for any questions that pop up. And then now I'll shut up. Thank you. James.
Thank you very much. Excellent. So our final keynote for CW24 is from Dr. Kelly Widdicks from the UK Centre for Ecology and Hydrology. Kelly is a software systems architect at the CEH. She focuses on responsible digital research infrastructure for environmental science, focusing on societal impacts, environmental impacts, sustainable human-computer interaction, and design principles guiding digital innovation. So Kelly leads a theme on decision-making under uncertainty for the Centre of Excellence in Environmental Data Science, as well as being a co-investigator on EPSRC's design principles and responsible innovation for a sustainable digital economy, which shortens to Paris-DE, but there was no chance I was going to remember that. So I'm going to hand over to Kelly, if you'd like to share your slides. Kelly?
Yeah, that's great. Thanks, James. You did a good job of remembering the name of the project better than I would do. That's not the worst acronym that I will share today either, so clever giggle at that. Yeah, so thanks, James, and thanks everybody for having me here today as part of the keynote. I'm really sorry I'm not there in person, but yeah, delighted to be asked. I've been traveling the last few days, so I couldn't be there, but really great to be here remotely, and also to see such a great hybrid participation at this workshop as well. So I've been at some of the sessions earlier today, and it's been really interesting. So I'm going to be talking about environmental sustainability and digital technology, and specifically digital research infrastructure. So this is where my kind of work has predominantly focused to date. And I'm looking forward to discussing a lot of this topic with everybody later and after this presentation part, because I think a lot of the things that I'll be talking about have been coming up in the panel discussion this morning, and also in that session just now on the kind of green software engineering. So let me try and the next slide. There we go. So just as a bit more context about me, James has done a really good job, so I won't do much about this, but my background's in computer science. I've done a PhD in sustainable human-computer interaction, particularly on how the way that people use services and the way that we design services and devices impacts the environmental impacts of the internet infrastructure. I've also been a researcher and lecturer in computer science at Lancaster University, again focusing on that research and environmental impacts of digital technology, but also a little bit on digital well-being and gender equality in computing. And now I'm a software systems architecture in the environmental data science team at the UK Centre for Ecology and Hydrology. So I'm focusing on the kind of co-design of digital research infrastructure with stakeholders, but also the wider impact that digital infrastructures have, including on environmental sustainability. So I'm part of a team that's called the Environmental Data Science Team at UKCEH. We're a team of nearly 40 now and still growing. We focus specifically on digital research infrastructure for environmental science, and we're broken down into kind of 4 sub-teams on data curation, DevOps, data science and design. I know Michael, who's in our data science team, has been there today, and Pfizer as well yesterday. And we take an agile co-design approach to our digital research infrastructure. So really trying to deliver value iteratively to people and involving people in that whole design too. And that's just a few of us on the slide there, as when we did some kind of co-design activity as part of our digital research infrastructure. So just as context of what I mean by digital research infrastructure, so for us, we're focusing on DRI for environmental science at UKCEH. So this will include things like monitoring infrastructure for gathering environmental data. It also includes the computational infrastructure for processing and storing that data, different digital assets like models and methods that we use, as well as digital tools within the science. So things, platforms that allow us to develop and analyze data, visualize it, and collaborate together. And we have a set of principles that we're working towards for DRI that colleagues and I are hopefully going to share with the community soon. But these are the kind of aspects cover that. Sorry, I think it's a bit of echo. But one of them, obviously, we've got cybersecurity, inclusivity, scalability, etc., and that co-design that I mentioned. But one of the ones that I'm going to focus on, obviously, today is that environmental sustainability. So really considering this within the design of our digital research infrastructure. And before I kind of focus on DRI specifically, I'd like to zoom out a little bit and provide some context about the climate impacts of ICT as a whole. And this will really kind of help kind of uncover the main key challenges in this domain and helps with that contextualizing the issues that are present for digital technology, but also ICT specifically and digital research infrastructure. So this was a piece of work that I did when I was at Lancaster University with colleagues there, as well as colleagues at Small World Consulting. And we did a literature review on the climate impacts of ICT and also looked at some new assessments of the ICT's carbon emissions from the sector with Small World Consulting. So ICT creates an environmental impact at each stage of its life cycle. And by this, I mean the embodied emissions released from the extraction of raw materials required for those technologies, as well as the manufacturing processes and the transport to the business or user. I also mean the use phase emissions or operational emissions from energy use and maintenance, and then the end of life emissions as digital technology is disposed of. And in this research, we aim to explore what ICT's emissions actually are from current estimates. And estimates of the current emissions of ICT or global greenhouse gas emissions so that it has a share of around 1.8 to 2.8 of global greenhouse gas emissions. And these estimates vary due to the different data sources used for those calculations, the recency of the data used within those calculations, and also due to the different decisions about what classes as in scope of ICT's emissions. So this includes the type of digital technologies to include, such as whether television or blockchain classes as ICT, as well as the elements of the carbon footprint to consider, such as scope 1 and 2 and 3 emissions. And we found that all these estimates actually underestimate the true environmental impact of ICT because of these differences, but also due to what is called truncation error, where ICT's full supply chain emissions aren't considered in carbon accounting. So taking in truncation into account, truncation error, we found that ICT's share of global greenhouse gas emissions is actually more like 2.1 to 3.9%, which is comparable to the aviation industry. We also found that estimates don't really take into account the activities of ICT innovators and end users that conflict with energy efficiency gains in ICT. For example, the kind of creation of novel device development or intensive device use. So that's what we focus on kind of current estimates. And when you analyse the studies projecting futures environmental impacts, there are quite a lot of differences that are dependent on a number of underlying assumptions, which aren't always made kind of explicit. And one of those assumptions is whether energy efficiencies in ICT are reducing ICT's carbon footprint. So efficiency has continued to improve in ICT, and some experts argue, for example, that there's been huge efficiency gains and carbon savings in data centres, despite global compute instances rising significantly, meaning that the carbon footprint of data centres has remained low. But if you look at the historical data, the demand for more computations and the number of devices per person has outpaced efficiency improvements, resulting in ICT's energy consumption and carbon footprint growing year on year. And this is a pattern explained through what is called a rebound effect, where ICT's introduction or efficiency can lead to an offsetting in those ICT emissions savings or an increase in the emissions overall. And I've got this shown as a diagram that my colleague Marcia Smith created at Lancaster University as part of a publication we had last year, which was trying to show, oh, I've gone too far, which is trying to show basically where you make an efficiency, where you've got the same amount of output, that surplus input then gets used for something else, which then we kind of create new output and then further emissions. So that's just trying to kind of show this example of what rebound effects are. Another big debate is whether ICT is kind of enabling carbon savings in other industries. And there are some estimates out there that kind of suggest that ICT has the potential to reduce emissions in other sectors. For example, the Global E-Sustainability Initiative suggests that the use and efficiencies of ICT for other sectors such as food or transport could enable a reduction in global emissions by 20%. And a classic example of how ICT is often seen as a way to reduce global emissions is through things like video conferencing technologies. So allowing people to kind of meet virtually instead of using physical transport like aviation. But there's actually little evidence in the past that efficiencies have led to a decrease in global emissions, and instead they've actually risen hand in hand with each other. So it'd be quite risky now to assume that ICT would start to kind of create those savings. So it's more likely that ICT is creating rebound effects in the sectors that it's delivering those efficiencies. And if we take that video conferencing example again, video traffic has increased rapidly, and emissions from flights have also increased too. So ICT is not a substitute here. It's only added kind of alongside that travel. So I think it's important to remember that ICT only enables those efficiencies in other industries if it completely substitutes the more traditional carbon intensive activities rather than being added in addition to them. And then the third assumption is a question on whether renewable energy will decarbonise ICT. So renewable energy has a much lower carbon footprint than fossil fuel energy, and the ICT sector are great in the fact that they are kind of paving that way for the global shift to renewable energy. And some experts argue that ICT's footprint could be reduced by up to 80% through renewables. But renewable energy still has a significant carbon footprint embodied in its infrastructure and supply chains, and there are limited resources such as silver required for solar energy panels that limit renewables. And focusing renewables on digital technology does kind of reduce the ability of other sectors to decarbonise as well. So whilst the shift to renewables is really important, it does not mean that we can just continuously kind of have that growth in ICT without considering that kind of wider aspect of its consequences. And whatever the position that the analysts that we looked at in this study on these types of assumptions, they all did agree that ICT would not reduce its emissions unless we had kind of major concerted effort involving broad political and industrial action. And under the business as usual case, the most optimistic projection saw that ICT's emissions would stay stable at the current level. And if they did, we would have something like what's shown on this chart here. So this chart represents global greenhouse gas or global CO2 emissions from 2020 to 2050. And the blue section represents whether non-ICT sectors would reduce in line with 1.5 degrees of warming. And if they did and ICT's emissions stayed stable, then ICT's share of global greenhouse gas emissions would become towards a third of overall emissions. And there's quite a big debate there to be had around whether ICT can form this kind of larger share if it's seen as a way to green the economy. But again, it's risky to assume that ICT would save more emissions than it contributes because of that historic data. And we really do need transparent evidence on this. In the work that we had, we argued that there's actually reasons for that ICT's emissions will increase. Firstly, because of this historic trend of ICT efficiencies increasing alongside emissions with the ICT sector and the global economy. Secondly, because a lot of the studies that are in this domain make important emissions on kind of important growth trends in ICT, such as artificial intelligence, the Internet of Things and blockchain. And then there's also significant investment in these trends as a way to green society, despite their own environmental impacts. So in light of these considerations, it is really risky to assume that ICT will by default assist in the attainment of climate targets. So that's ICT's environmental impacts as a whole. And I think that really helps with that kind of understanding the assumptions around environmental sustainability and digital technology. And this helps thinking again about what's specific for digital research infrastructure too. So in the last few years, there's been a project called the UK RI Net Zero project run by CEDA. And this has been exploring what the key issues of DRI, environmental sustainability, are. The report came out last year, and this provides a number of recommendations for sustainable DRI, including a roadmap for that net zero UK DRI. And this project had a number of smaller projects that fed into this report, one of which was this project called ARINSRIT that myself and colleagues at Lancaster University, Bristol University, the EPCC and STFC were involved in. This is the awful acronym I mentioned at the start of my presentation called ARINSRIT. But it basically looked at the kind of socio-technical aspects to DRI and environmental sustainability. And this is what I kind of wanted to talk to you all about today. So ARINSRIT specifically aimed to understand how DRI's environmental impacts are shaped by research practice and culture, and also to explore what opportunities actually exist to intervene within the DRI system and kind of research cultures currently to reduce the environmental impacts. And this involves 25 interviews across DRI stakeholder groups to really understand that overview of research practices and culture. So it wasn't just people who use digital research infrastructure, but also who provide it and commission it and manage it too. And a lot of the findings that I've got to talk about here were actually things that were discussed earlier on in the panel session, which is great. And I think it's just really great to kind of see that the awareness around this topic is growing. And firstly, we saw that the kind of DRI use is increasing, even in domains that weren't previously seen as kind of compute intensive. And there's lots more wider groups of accessing this, including kind of students within bachelor's degrees. So demand is really driving that growth, and that demand is outstripping supply. And we're ending up with kind of what's seen in the quote here, where we end up in another cycle of growth. So the more we add, the more we use. And then there's that demand is more than supply. DRI use can also be inefficient, and for example, with poor software engineering practice or unnecessary compute, and it can also be unsustainable. So, for example, DRI procurement is often driven by the funding availability at the end of financial years, rather than the kind of purely driven by need. So there can be unsustainability within the cultures that we have in research. And then the FAIR principles could be as a way of kind of supporting that reuse of data to avoid unnecessarily duplication of DRI for storage or compute. But this in turn also requires kind of an ecosystems of tools to support FAIR assets. And it might be that when we reuse stuff, we might be able to use them more once we kind of make them more fair. So it's just these things that we need to be considerate of. Academic practice also shapes some of this inefficient DRI use and provision. So, for example, quite often people like to have their own unrestricted, uncontrolled DRI that might lead to kind of extra local DRI that's increasing embodied emissions and disposal as well, I guess, on that side and use. There's also a lack of understanding and awareness and training for DRI, a sustainable DRI, because of the environmental impacts being so quite difficult to contextualize. And then if people are aware of them, they don't always know what the right thing to do is for sustainable action. And when there is some action, it might not necessarily result in something that's more sustainable. So we might be kind of having this focus on energy efficiency. There's also little oversight and resource dedicated to net zero DRI, and this means that there's kind of little pressure to kind of embed this into the DRI activities. And this was an issue, again, that was raised earlier today. So before I go into kind of recommendations from ARINSRIT, I also just wanted to provide some initial insights into some work that we've been doing at UKCEH that's not been published yet. But this was a kind of specific case study of sustainable DRI at UKCEH, trying to understand what people do currently for sustainable DRI and what we could do as kind of an action, what were the barriers that we need to be addressing. So this involved 4 workshops at each of the UKCEH sites to kind of start this conversation. And again, whilst there was some consideration to date on what could be done to support sustainable DRI, it was a kind of similar story. Not many people knew about it, but really did want to know more. So there was lots of questions about what is the footprint of DRI, what's worth worrying about, what should we do on one side, what should we do in terms of the different kind of trade-offs to make. And these questions, as mentioned, kind of specifically focused around the different ways of using sustainable DRI and wanting to understand which way is better. So is it better to kind of work locally or in the cloud? And the same goes for whether what's kind of sufficient to people. So is some DRI always needed? Could we use less DRI? Do we need as much DRI for the kind of accuracy or instant access kind of questions? So there's a lot of more questions that people actually want to know when they're using DRI, so that helps them kind of make informed decisions. And similar to those findings that in ARINSRIT, in terms of the barriers for sustainable DRI, there was a lot of barriers discussed in the workshops, such as agency. So, you know, how much can people actually do about this, especially as digital research infrastructure is kind of managed externally to organisations. Secondly, on resources, including having that time and support for sustainable DRI. Thirdly, on constraints, so constraints from kind of other aspects of technology that might counteract with sustainability, such as lifespans of technology and also things like cyber essentials and waste. And then finally, on culture. So again, you know, we've got funders that demand new data and analysis. How do these types of culture kind of impact as a barrier to sustainable DRI? So in ARINSRIT, we developed kind of 3 sets of recommendations for a variety of groups involved in the provision, use and disposal of DRI. And the first, we had 5 around the governance and management of digital research infrastructure. And these involved, for example, creating new policies on digital research infrastructure to be established from transparent evidence of DRI's environmental impacts. And these need to be informed by consistent and full life cycle assessments. So thinking about that, those full life cycle assessment that I talked about right at the beginning. We also had recommendations around promoting fair and net zero research incentives, such as kind of creating statements in funding applications on sustainability, which again linked to some of the discussions earlier today. The second set of recommendations followed those that are involved in the provision and support for DRI. Again, thinking about that training on sustainable DRI. So, you know, I thought that's what the green software session that we had just then, there's that sharing of tools and knowledge and what's out there to use. And I learned something new as well. So it was really, really useful. And also kind of things like clear decision processes in funding applications, so whether that DRI use is actually required, and thinking about what the environmental impacts of that DRI use would be, using those consistent methods for calculating the environmental impacts. And finally, the last recommendation we had was around users, which focused on ensuring users kind of follow best practice in the sustainable use of DRI, but still recognising the need to advance knowledge in this domain. For example, by exploring some of those questions that my sustainable DRI workshops in UKCEH uncovered. So to summarise, there's so much more work to be done when it comes to sustainable digital technology and digital research infrastructure specifically. We really do need to understand more about the environmental impacts of DRI, considering the full life cycle impacts and emission scopes, as well as impacts beyond emissions that are focused on today. And more qualitative understanding on how, the outputs and the gains of that science compare to these environmental impacts, and whether we should be doing some of the things that we are doing. But waiting on concrete numbers is, shouldn't stop us from taking action. And so as part of this, we really do need more tools and methods and different processes in research culture that support sustainable DRI decisions across a variety of stakeholders. And it was great to see some new tools in that last session just then that I've not seen before. So thanks for everyone that was involved in that. And for me, this really does require a concerted effort across the community, so helping enhance knowledge of DRI funders, provisioners and users to ensure that sustainable action is taken. And just to summarise, I think for me, this really does require an approach that centralises systems thinking and co-design. So systems thinking is needed because as soon as you start to consider the digital research infrastructure as an entire system of different technologies, the full system's complete life cycle and impacts of those technologies, and the various ways that different stakeholders involved in DRI actually use it and provision it, dispose of it, that actually affect the environmental impacts of the technologies themselves, then it's only then that you can start to see issues such as rebound effects and how cultures impact emissions, and that will help us uncover innovative solutions. And co-design again is central to me, as this is only when we're going to start making these innovative solutions work if we really do involve the community in creating those solutions. And so that's what I wanted to end on today, is that importance of an approach, I think, for tackling this issue of environmental impacts of digital technology and digital research infrastructure specifically. That concludes my talk. I'm really sorry if I've gone over on time, but thank you all for listening, and I'd now like to open up to questions.
Please, a round of applause.
Thank you.
Thank you very much, Kelly. I think we've probably got a bit of time for some questions because we started a bit late. So yeah, I'm getting a thumbs up there. So great. So thank you ever so much for the presentation. It's amazing. And I think it synthesizes a lot of what people have been talking about over the last couple of days. So Loic has a question. Brilliant talk. Thank you. What are the main data gaps that you have identified regarding energy usage, environmental impacts of ICT in the UK in particular, and how would you go about plugging them?
Well, that's a really good question. I think that, yeah, I think in terms of main data gaps, I'd be thinking about those kind of a more emerging technology or kind of technologies that haven't been assessed necessarily too much so far. So things like artificial intelligence and Internet of Things, and really then help having that kind of full overview of the ICT sector specifically. I think also for me, having a knowledge about how the way that people do things and how systems are designed and how that then impacts the environmental impacts. So having some tools that help us design that. And again, rebound effects, because that seems to be always the thing that we keep coming back to, how do we kind of assess those? That's really, really complex because they're in the future and they can, can show in so many different ways. So I'm not sure how I would go about plugging each of those. But again, I think for me, it comes down to kind of this whole systems complete approach and involving all the different people that are involved in the environmental impacts of digital research infrastructure. So I hope that gives a brief intro.
You're
but I'm
getting a
happy to
nod
chat more.
from Loic, so he's quite happy with that answer.
Okay,
Well
that's
done.
fine.
Excellent. So the next question, which has bounced right up to the top of the list from Anonymous, I'm interested to know if you have any ideas on how to bring together reduction in digital research infrastructure carbon footprint, co-design, and a just transition with the Global South having a voice. So that's a big question.
Yeah, that's a really interesting question. I think for me, I don't know if I'm going to answer this question right, but for me, it's about that co-design approach. You know, if we're making sure that we're getting a variety of different people involved in that process, then we can make sure that they're kind of considered in the whole innovation process, so making sure that it's responsible. So I would just really kind of emphasize that need for kind of co-design, but that's part of the question, so I'm not sure whether I've answered that one quite right. But for me, it's about making sure that that co-design process is kind of robust and involves a variety of different people.
Excellent. Thank you very much. I think we've got time for one more question. So is there an argument for considering the societal benefit of outputs from digital research infrastructure, such as weather forecasts, as a mean of offsetting emissions?
Yeah, definitely. So I think that's what I was trying to get to in the last point on my understanding. I think we really do need to understand exactly what digital research infrastructure is being used for and the positives that it creates, and how do we do those trade-offs with the environmental impacts that it has. And that gets really, really difficult because some of these things can be quite values-based, and they, you know, different people have different values, and how much do you put on kind of health research versus environmental science research, etc. So it is a really kind of complex issue there, and I think that's just where we're going to need more research on understanding those different trade-offs.
Excellent. I think we'll probably wrap up the questions there. Can I ask for another round of applause for Kelly? Thank you.
Thanks very much. Lovely to talk to you all.
And I think I shall now hand back over to the big boss.
Not the big boss. I'm gonna